Hi, in this video we'll go through exercise EM-1 and I will try to explain what kind of delivery is expected here. Let's look at the task again. Here it is. Just stop the video if you need to. So we'll have to work with 3 pumps here, and for each pump we'll have to try 4 different motors. So we'll have to design 12 systems. Don't worry, in DriveConstructor it is fast. First, we need to figure out right system topology. How do we choose one? Well, we know that medium voltage topologies always include some sort of a transformer, while low voltage drivetrains can be built both with and without transformers. So, since we have to analyze motors with 3.3 and 6 kV voltage level, we will have to use topology with a transformer. What else do we know? The rated speed of the 3 pumps is the same and is just below 3000 RPM. This speed is already high enough to couple some standard motor directly to the pump, so there is no need for any gearbox. So I would propose to design all the 12 systems using the same topology, the one with a step-down transformer. By the way, it is shown in the exercise description. The only one thing of interest for us in each system is a motor, electric machine. I mean, we'll be building different systems so that the machine voltage is at the level we need. One of non-obvious things here is type of frequency converter. The matter is, for example, 3-level neutral point clamp converters are usually used for 2, 3 or 4 kV, while series connected H-bridge converters for 6 kV and higher. That means, if we need a system with 3.3 kV machine, we should use 3-level NPC converter. If we need 6 kV machine, we should use series connected HB. And here we have to take into account that these converters will need different transformers. Okay, let's try it out. So we select pump application and take the topology without gearbox and with a transformer. We press on new system. First we set up right parameters for the pump according to the task description. So we shouldn't forget to correct efficiency to 85. And now we go into motor menu and choose right efficiency class IE3 for the motor. As the next step we set the voltage for the transformer to the correct level around 400 volts. And we can see that the curve for the pump is right below the system load curve, so everything is correct. So now let's see, DriveConstructor offers us 2 options for frequency converter, wall mounted and floor mounted, and we choose the cheapest one, wall mounted of course. So now we see the show report button gets clickable, so we can see all results of sizing here. We can save the system under some name like 400 volt system in this case. And now if we scroll up, we can find our system under My Systems menu. So here we can either go to sizing results or to the topology itself to change parameters if we need to. So that was the system for 400 volts, and now let's make a system for 3.3 kilovolts. So we do exactly the same. First set up pump parameters. We need to do this again, and efficiency. Now do not forget the motor efficiency class IE3 as in the previous case. And now we should use very special converter topology, 3-level neutral point clamp converter, and we should correct not only voltage of the transformer but also number of windings to 3 windings, so the converter and the transformer match with number of connections. Now show report, we see all the parameters and we can save the system again under the new name 3300 volts. So, and we find then both systems in My System. Please note that the weight here is total system weight, not just electric machine weight. And the same for the price and efficiency, it's system parameters. So we should be really careful here. We should, after you have produced data for the 4 voltage levels, you can summarize the data in a table on a chart like this one. Here we have 2 vertical axes, one for weight and one for price. Then, after you have depicted the motor's weight and price against different voltages, you probably will be able to reflect on why the voltage level the motor is designed for affects the motor weight and price in the way you just identified. Has this something to do with thickness of the main wall slot insulation, or inter-turn or face-to-face insulation? How heat transfer from the copper wires to the laminations is affected by the insulation? How heat transfer and temperature distribution inside the motor affects size of the motor? How then price of the motor depends on its size? Well, you may want to write a few lines of your reflections. That's it. Thank you for watching and good luck.